convex mirror quiz on 4/29/14. So number 1, you are given a convex mirror. Center of curvature -20, focal point -10. Have you screwed up already, or are you okay with that? Okay. Focal length, remember, is always half of center of curvature, and for a convex mirror, they're both negative. Always. Okay, so we have an object placed 25 centimeters in front of this mirror, and just to give you the visual, so remember, with a convex mirror, we are looking at the mirror being out on this surface. Okay, the mirror is on the outside of the bowl, as it were. If you take a big stainless steel mixing bowl, shine it to a high polish, and flip it up and point it at people, you have a large convex mirror. So our focal point is somewhere there, our center of curvature is somewhere there, and our object is somewhere out here. So that's just to get it conceptually. And sometimes I actually sketch for myself a little. This is not to scale. I'm not going to do a ray tracing here. It would be a disaster. But I'll do that to remind myself where everything is. Because if you're a real visual learner, it helps me to go, oh, okay, and this is positive, and this is negative, so this is a negative number, and this is a negative number. Okay, I got this. All right. Okay, so we're going to use our basic mirror equation. It's the same thing we use for any kind of mirror, no matter convex, concave, whatever. And we can just plug numbers into this once we've rearranged. Okay, so, yes, that is oh, hold on, that's not negative. Yes, it is. Yes, it is. That's negative. Sorry. Okay, so we get a -7.14 with sig figs, -7.14 centimeters. That negative sign tells us that this image is behind the mirror. That tells us the image is virtual. Remember, if you have a convex mirror and you tell me the image is real, I automatically take away your birthday, your firstborn puppy, and a quart of your blood. Because a convex mirror can never form a real image. So for magnification, we get negative of q over p, negative of -7.14, etc., divided by 25. We get a magnification of 0.2857. The fact that this is less than 1 tells us that it is reduced. And the fact that it is positive tells us this is upright. Okay? Now, let me ask you, what kind of mirror is the side view mirror on your car? It's a convex mirror. You get a larger range. Why is there the disclaimer, objects in mirror may be closer than they appear?
Because convex mirrors make things shrink.
Because convex mirrors tend to produce reduced images. So your brain says, oh, it's little, it's far away. But it's not always. So you can't always trust your brain. You have to do a mental adjustment there. Okay, so on their paper, they get a point for having -7.14 centimeters for Q, a point for having, these are all imaginary points, they're all made up, you realize that? A point for having magnification equal to 0.286, and a point for virtual, a point for reduced, and a point for upright. So, 5 points. Okay, so we've got, this is set up, it's a little hard to draw to scale on here, so I did the best I could. When doing these mirrors, this is a spherical mirror. So you just make a circle and erase half of it, you've got it, and that's what we talked about using the compass for. So I think my focal point's probably a little bit off. My measurements are approximate because I don't have a scale on this thing. So remember that your first ray, and I'll use the straight line drawer, goes from the object to the mirror. So that is an inbound ray. Well, then it reflects back through the focal point. So a line that connects the focal point to that point and keeps traveling. Except this part is virtual. Okay? That is, it's there, but we don't really see it. And my line is not parallel to the principal axis, but it's the best I can do right now. It's tough to draw these on here. Okay, our next ray connects the object to the focal point inbound. And remember, you don't want to show any of the inbound ray behind the mirror. There are no inbound rays behind the mirror. Nothing can go through the mirror. The reflected ray comes back parallel to the principal axis, and there's our outbound. So that was inbound, that was outbound. but it continues behind the mirror, whoops, in a virtual sense. So we do our little line back here and that, okay? So far we've got a point where they're coming together, okay? Like I said, the convex mirrors are the ones that screw people up the most. For some reason, drawing those lines behind the mirrors just twists people's heads around. Okay, our last ray is going to connect the object and the center of curvature, and it's going to go right through. Now that one actually looks pretty good. And that is the same line is the inbound and the reflection.
Wait, explain that one again. What is that one?
Connecting the object to the center of curvature. Important. Only the reflected ray shows up behind the mirror. The inbound ray cannot show up behind the mirror, and if you do that, you're wrong. Would this object be virtual? Yes. Would it be reduced or enlarged? Reduced, which confirms what our calculation said. Would it be upright or inverted? Upright. So this confirms our calculations. Now, obviously, this is not done to scale very well, but it gives us a rough idea. Okay, so we plug in the numbers that we're given, and we get a Q of -5 centimeters. So this appears 5 centimeters behind the mirror. Let's do a quick magnification. Okay, so we do our magnification, we get 0.500. So the negative here tells us this is virtual. Less than 1 tells us this is reduced. And positive tells us that it's upright. So fairly simple. Let's do the drawing. We have our mirror, we have our focal point, we have our radius of curvature. First line goes in parallel. Whoops, that's not parallel. In parallel. Ah! Okay, it's not parallel, but it'll have to do. And then reflected back out, connecting that point and the focal point. And that didn't quite connect them, but hey, again, it'll have to do. Oops. And we want to make sure that this line back here is virtual. And we're going to put arrows on these to indicate incoming and outcoming rays. There's our first ray. Our second ray, make this one green, connects the object to the focal point. And of course, it's an inbound ray, so we do not see it behind the mirror at all. And no, inbound rays never appear behind the mirror. And then it's reflected back perpendicular to the principal axis, or parallel to the principal axis.
Can't you make the dotted
Now,
dash line?
it's going to be
Oops. You can't make the dotted dash line thing?
for the incoming? No.
No, I mean...
Yeah, you can.
Okay, so we have the reflection line on that second ray appearing behind the mirror. Now, right now, it looks like we're getting an intersection. That's a good thing. Now, let's do our third line and hope that our third line confirms that. We'll do a nice little purple ray. And that's not even close. We'll go from the object through the center of curvature. Woo! Look at that. And that virtual line behind the mirror intersects the other two right in our sweet spot. So, is it virtual? Yeah, it's behind the mirror. Is it upright? Yes. Is it reduced? Yes. Everything that our calculations claimed it was. So, this would be considered a successful drawing. And you'll have more opportunities to practice on that stuff.